What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to be going over converting our camera from Blueprint to C++ yet again. In total, we've had 5 episodes, this is the 5th episode, on the subject. And so, specifically in today's episode, we're going to be going over setting the inner and outer boundaries in the code. Our inner boundaries are these ones, like if we get too far apart, we can't go any farther apart from each other. Our outer boundaries are the absolute maximums of the map, like we cannot go any farther right regardless of our other distances. And we cannot go any more to the left at this point, regardless of our other distances. If you want to get caught up in the series before checking out this episode so you can see how we've done everything from hitboxes, auto combos, combo counters, and a lot of fun stuff like that, feel free to click this link in the top right corner right here to see how we've done every episode in the Fighting Game Tutorial Series playlist. Alternatively, if you don't care about that and you just care about the camera and a C++ camera, I recommend you watch the first episode of the camera so you know the behavior that we're starting with before we convert it to code. I'll link that episode right here in the top right corner as well. Now with that out of the way, we can go ahead and get started. This series is a code and blueprint tutorial series, but since we're converting things from blueprint to code today, we're going to be doing everything in the code. We're going to be using the blueprints for reference. First things first, we need to go to our camera blueprint. So for me, it's in blueprints, functional BPs, cameras, base camera BP. So in here, we've tackled almost everything in this blueprint in code, except these 2 events, freeze camera and resume camera, which is for special occasions like super moves. And then a few of our functions, specifically set inner boundaries, set outer boundaries. First things first, let's go into set inner boundaries and let's get started. So this is a function that determines where those inner boundaries are placed. The function takes in a Boolean parameter, is player 1 on left, which we can pass in directly from determine left player. And that's actually what we do in the blueprint when we call this function. If we go back to the event graph and go to event tick, determine left player gets called, and then set inner boundaries gets called right afterward. We'll be calling this function in tick after we create it. So going back to set inner boundaries, let's start creating this function. We go into the code and we go to our camera class, specifically basecamera.cpp and basecamera.h. Then we scroll down to where we want to make this function. I'll make it below the other functions that we made here. So determine the locations for the inner boundaries and assign them. This is going to be a U function, blueprint callable, if you want it to be. Since we're creating this in C++, we don't need to call this in the blueprint, but if you want to have a camera blueprint that's a child of the code class, like you have a specialized camera, you could do that. Then you'd be able to call this function in here. But it is up to you. So this function doesn't return anything. If it did, we would see return nodes all throughout. So we don't need a return type, so it is going to be void set inner boundaries. I'm going to actually change this though and say void calculate inner boundaries. It does set the inner boundaries, but the word set typically refers to setters and mutators, and this is not that. It's going to be doing some math, figuring out where it should be placed, and then placing it. And it's going to take in a boolean is team 1 character on left. Alright, and while we're here, we can go ahead and make the other function. So determine the locations for the outer boundaries and assign them. U function of blueprint callable for the same reasons as above. And if we go to set outer boundaries, you'll see this doesn't have any return nodes either. So it is void, and it doesn't have any parameters that get passed into it. Void calculate outer boundaries. Just like that. And those are our 2 functions for today's episode. Now we want to go to the CPP file, basecamera.cpp, and make these functions. So I'll put them above tick. Void a base camera, calculate inner boundaries. And again, it has bool is team 1 character on left, and we're calling it that instead of player 1 because we do support team modes now as well. And then we can make our other function, void a base camera, calculate outer boundaries, just like that. So we have set inner boundaries. Now the first thing we do is actually perform an if statement or a branch on our boolean that gets passed in, and that determines what character we check for all of our values here. So we can start off with this. If is team 1 character on left. So we have if and else. Now, first thing we do is check our game mode reference and then get our active team 1 character from it. If these are both valid, we continue. So we've done the game mode and active team 1 character reference a lot throughout the camera class. You can see right here is team 1 character on left we do it. We also do it in the tick function right here. So we can do if auto base game mode equals cast a fighter template game mode, and we're casting the worlds, get world, get auth game mode. So basically, if the game mode exists and it can be casted to our fighter template game mode, that's the game mode we want to use for this check. The reason we want that game mode is because it has access to the active team 1 character and active team 2 character. Base game mode, active team 1 character. So if this one is valid, then we'll go ahead and continue into this if statement. So that is all of these nodes knocked out. Next thing we're doing is making sure that the active team 1 character's combo state is not equal to launched. This is important because when the character gets launched, we don't move the inner boundaries. This is so the character can wall bounce off of them if they get launched into them. We can say if base game mode active team 1 character not equal to e combo state : e underscore launched. Then off of active team 1 character, we look for get combo state, which we made earlier in the series. This just returns the current combo state on the active character. So if it's not equal to launched, we can go into this if statement. And this if statement is then going to get the active team 2 character and check for the same thing. So let's go back to the code. This is very simple at this point. You could do another if statement in here if active team 2 character and if team 2 character is not equal to launch, but you'll notice that in the blueprint we don't do anything if it's false, so we don't really need to separate these conditions. So to make our lives easier, I'm going to do a little change here to the code where we are going to check for the active team 2 character in the same check as the active team 1 character, even though we weren't doing that in the blueprint. And then in the same condition here, where we were checking to see if the active team 1 character is not launched, we can check if active team 2 character is not launched. So to do this, we can add an and basically just copy this whole thing. If the active team 2 character combo state is not equal to e combo state launched, just like this. And you can keep it all on this line, or if you want, you can enter it down like that. And that will also work, but now you can see it more easily on the screen at one time. But basically, if neither of the characters are in the launch state, we can go into this if statement. Back in the blueprint, you can see we're doing some other things below these branches, or these if statements. Specifically, we were getting the actual location of Team 1 character, modifying the Y value by -200. Remember, this character is on the left in this branch. So we were subtracting 200 to get it farther to the left, and making a new vector out of that. And then for active Team 2 character, we were doing the same thing, getting their location, adding 200 to the Y value, and then making a new vector. This is because we were setting the actor locations 200 units apart from the characters on each side. This is an arbitrary value I selected, but this is your buffer between the character and the inner boundary. There's also another section here that we have to be aware of, and that is that the difference between the Team 1 character's Y position and the Team 2 character's Y position is greater than 700. If it's greater than 700, they're too far apart. They're at their maximum bounds. At this point, we don't want to move the inner edges at all. They're already at the maximum, so don't move them farther away from each other. So let's start implementing this. First of all, to actually get these values, we go into our if statement here, and we say f vector left inner boundary location equals base game mode active Team 1 character get actor location. So this is this first part here. And then this break vector minus 200 on the y, making a new vector. It's just basically modifying the y value. So we can do left inner boundary location dot y minus equals 200.0f. And we can change that to a variable, but for now I'm just copying it directly from here. And that will simply apply this straight to the f vector. So we don't have to make a new vector or anything like that. And for our right boundary, we're going to do the same, just opposite. We're adding 200. Clean it up like this. Let's make our two vectors next to each other. Right inner boundary location equals base game mode, active team 2 character, get actor location. And then here we're going to say right inner boundary location plus equals 200.0f. Make sure you write .y at the end of this. You're not adding it to the whole location, just the y value. Now at this point we need to check and make sure the character's y locations are not greater than 700 units apart. I'm actually going to do this above setting the inner boundaries, because if we set the new locations and then we don't end up using them, it was just wasted processing power. So if base game mode active team 1 character dot get actor location dot y minus base game mode active team 2 character get actor location dot y. Let's change this to an arrow. Is greater than 700.0f. So only if it is do we go into here. And like I said, if you want, you can go ahead and do something like that to make it look a little bit cleaner, because I know these lines get kind of long. So now only if the distance between the players is greater than 700 units on the y-axis will we set these inner boundaries, and then when we set these inner boundaries, we're just going to take the locations that we made from the make vectors, which are the new variables that we created. So specifically, left inner edge is going to be set to the location that we calculated from player 1, which is going to be our left inner boundary, and right inner edge is going to be the location we calculated from player 2, which is right inner boundary. So now we should have these boundaries because we set them up in the previous episode. So left inner edge, set actor location. And we're going to pass in left inner boundary location. And we're going to do that for right inner edge as well. Perfect. Now we copied this over exactly as it was in the blueprint with a few modifications where I mentioned them. We definitely don't need a whole else statement to handle this because it's very, very similar. It's just going to reverse the active team 1 character and active team 2 character. Their positions are setting the other boundary, so if player 1 is on the right, they're going to be setting the right boundary and vice versa. So one thing I'm going to do to clean this up a little bit is move the game mode cast outside of the top if statement, because we don't need to calculate this twice. If it really is not valid, then we don't need to do anything else in here. The game mode should absolutely be valid. So instead I'm putting everything inside of this function in this if statement. Also, going off of that same statement, if we really do have an if and an else, and we're checking if player 1 and player 2 are valid on each of these, then we can also move this if statement outside of the initial if statement that is team 1 character on left. To delete your brackets properly and fix up your spacing, let's keep following this idea because we can really clean this up a lot. So the next one, checking to see if they're in the combo states. This doesn't matter what character's on what side, so we can go ahead and take this if statement out and put it above is team 1 character on left. If we do this, again, just remember your brackets. That way we don't mess anything up, right? We want everything to be exactly the same as it was. We're just moving these things. And the reason we're moving them is so we don't have such similar logic in the if and the else statement. We're going to check these both times, so why copy so much logic? Guess what? We can go ahead and do it to the next if statement as well. We were checking the difference in location of these actors. Now there was something I didn't do initially when I wrote this line that we were doing in the blueprint. Let's take another look at that. We were getting the difference of the two locations on the y-axis, but we were grabbing the absolute value, so it doesn't matter which direction the characters are. This also defeats the purpose of doing it in the if or the else statement. We should just do it above. So this difference that we get is going to be handled for us if we put it in an absolute value statement. We can use fmath, : abs. And this will grab the absolute value of whatever we pass into it. We want to pass in everything, the difference. So now we have fmath abs of active team 1 character get actor location.y minus active team 2 character y location. That whole thing is in absolute value, and we check if it's greater than 700. This means we can pull this out and put it in this if statement. Okay, now when we do this, every single thing that we had, every other condition that we had, is now outside of the is team 1 character on left. Good. That's really all we need, because now we can just copy these lines and paste them in here. If you want, you could even clean it up more than that, but I think this is enough for today's episode. So this time what we're going to do is set a left inner boundary location and right inner boundary location, but in the else statement we're going to flip them. Left inner boundary is now for team 2 character, since team 2 character is on the left, and thus they should be the starting point for the left inner boundary location, and vice versa. For the right inner boundary location, we're going to use base game mode active team 1 character get actor location. Now, left inner boundary location.y is still minus equals 200, and right inner boundary location.y is still plus equals 200. These don't have to be in the if and else statement, and neither do the set actor locations. These are the same lines. The only thing that we need to put in this if statement is this right here. So if statement, else statement, slightly different. Everything else is going to be exactly the same, so I'm going to go ahead and cut them out of here. Why do this logic twice and make our code more confusing? So after the if and else, go below it and paste this here. And the code doesn't like that because we made a variable in these if and else statements, but we can fix this by simply removing the f vector here. And making them above the if statement. F vector left inner boundary location, right inner boundary location. So we make the two f vectors above because we know we're going to use them regardless of which condition we take. Then we set them appropriately in the if and else, and then we add our modifiers onto the end and set the locations. This is what calculate inner boundaries should look like. Next thing we will tackle is calculate outer boundaries. I really hope you enjoyed the content of this episode, and if you did, please subscribe. It does more for myself and the channel than anything else you can do. I want to give a huge shout out to my YouTube membership, Patreon members, and Discord supporters. You guys are amazing, and you keep this series alive, so thank you for all the love and support. I cannot say it enough. Thank you. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and all the support is completely free. Anyway, guys, like I said, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Bye, guys.